All right, boys and girls, lesson 39 coming at you. Problem set 39. So today we don't have to actually learn anything new. We're just doing word problems. So it says to use the RDW process. So remember that's read, draw, write. I will probably only draw for a couple of them, and we'll just draw a tape diagram, but feel free to draw for each one. But we actually only have 6 problems on this. So we're doing the same work we did yesterday and the day before. All right, so Tamika ran 2 5/8 miles. Her sister ran twice as far. How far did Tamika's sister run? So twice means we're multiplying by 2, right? So her sister, circle, underline, box. Make sure you circled the 2 5/8. I would also circle the word twice because it's still, even though it's the actual word, it's telling us how many times. Underline Tamika and her sister. And then box, how far did Tamika's sister run? All right, so we take our 2 times 2 5/8. Now remember, we're going to distribute that 2 to both of those. Why? Well, let's do a tape diagram. Actually, we'll do 2 tape diagrams, and I'll show you. This is 2 5/8. My 2 should be bigger, sorry. This is 2 5/8. That's twice, right? There's 2 of them. Oops. Let's take out this 2 separate and this 2 separate. So we have 2, 2, but then we have 2 5/8. Oops, sorry about my 5. Well, here's our draw part. So we have 2 of these. So we have 2 of these, and we have 2 of these. So that's why we have to multiply that by 2. Okay? So these are the same thing. They're showing the same thing. They're just kind of set up a little bit differently. So erase that. So we are doing 2 times 2 plus 2 times 5/8. What's wrong with my 5s today? Okay, 2 times 2 is 4, plus 2 times 5 is 10/8. That one I can just pull out 8/8. That's an easy one. 2/8, that's 1 whole. So that's 4 plus 1 and 2/8. Now, of course, you could have gone over here and put 8 into 10 once. 1 times 8, 8, subtract, we have 2/8. But I knew that was going to be a pretty easy one there. We add those together, 5 and 2/8. So Tamika's sister ran 5 2/8 miles. There's number 1. Moving on to number 2. Natasha's sculpture was 5 3/16 inches tall. Maya's was 4 times as tall. How much shorter was Natasha's sculpture than Maya's? This is a 2-step problem, boys and girls. Or, actually, not necessarily. Let's draw this. Natasha's sculpture is 5 3/16 inches tall. Maya's was 4 times as tall. Oh, I don't have enough room here. Let me turn this sideways instead. So this is Natasha, right? Yeah. Just gonna label that. Whoops. Why am I labeling on the inside? Can you see that? There we go. Okay, here's Natasha. And she's 5. What is it? 5 3/16. Maya's was 4 times as tall. So we draw 4 of these. 1, 2, 3, 4. What's her name again? Maya. So it's 5 3/16. 5 3/16. 5 3/16. 5 3/16. How much shorter was Natasha's sculpture? So here's the thing. You probably thought, oh, we should multiply by 4 because there are 4. But really, we're only actually going to multiply by 3 because we want this difference. Crazy. I know, right? But we want to know, that's why this is a really good time to draw this. We want to know how much shorter basically hers is. So we need to actually add these, which could add them, but we'll multiply by 3. So we're not multiplying by 4. So this was a tricky one. I think we all probably would have gotten that one wrong if we were doing it in class. So 3 times 5 3/16. Distribute our 3 to both of those. I'm going to do it quickly here. And so I'm going to not skip a step, but not draw a step. So I'm just going to do 3 times 5, which is 15. Well, it's not quickly. I'm just trying to conserve space. And 3 times 3 is 9/16. Oh, so it's 15 9/16. That was a good one. So your answer statement should be Natasha's was 15 9/16 shorter than Maya's. Good one. This in class, I probably would have assigned, I would have put you in groups and assigned each of you one or two problems, and then we would have put them up on the board. That was a really good one. All right, a seamstress needs 1 5/8 yard of fabric to make a dress. I'm going to start drawing this right now because I don't trust these word problems. 1 5 to make a dress. My D is going to stand for dress. She needs 3 times as much fabric to make a woman's dress. How many yards of fabric does she need for both dresses? Oh, so, this is okay. So she needs 3 times to make a woman's dress. So this would be the woman's, right? 1 5/8. You probably would have solved this a different way. I bet you most of you would have added all of this. So we're going to multiply though, because that's what, we've been doing, is solving multiplication comparison. Comparison word problems involving fractions. So we're not actually multiplying by 3 though. I know to make a woman's dress is by 3, but we want to know for both dresses. And since they are they're not the same, but each part of the tape diagram stands for the same thing, we can multiply by 4. So we're doing 4 times 1 5/8 because we need 4 sets of 1 5/8. Yeah, we definitely need to draw these, that's for sure. So 4 times 1 is 4, plus 4 times 5 is 28. So 8 goes into 20 twice. 16, 4, and so 4/8. So this is 4 plus 2 4/8. Add these together, we have 6 4/8 total is needed. So you would write, the seamstress needs 6 4/8 yards of fabric to make both dresses. These are good word problems. I like them. You see? Yeah. All right. A piece of blue yarn is 5 2/3 yards long. 5 2/3. Here's their blue. A piece of pink yarn is 5 times as long as the blue. 1, 2, 3, 4, 5. So each of those, Bailey tied them together with a knot that used 1/3 yard from each piece of yarn. What is the total length of the yarn tied together? Ooh, that's a complicated one. A piece of pink yarn is 5 times as long as the blue. Bailey tied them together with a knot that used 1/3 yard from each piece. I keep saying yard instead of yarn. What is the total length? Well, what's your thought on starting this? Should we multiply first? Are we multiplying by 5? No, because we have the blue one too. So let's multiply by 6 and see how we do. Okay, so 6 times 5 is 30 plus 6. So we know that 12 divided by 3 is 4, 34. So we have the answer of 34, but that's not the answer. And we know that because we have to take off 1/3 yard from each piece. So how many yards are we actually taking off? 1/3 from each, or from each color, excuse me. So that would be 1/3 plus 1/3, which is 2/3. Okay, so I've got to erase this part, but we have our 34, and we have to take away 2/3 because that was used for the knot. That's kind of cool. So I would say take 1 here, and this becomes 3/3, right? So you can do 3/3 minus, well, let me start with, here's our whole number, 33. And then 3/3 minus 2/3 gives me 1/3. What an excellent one. I love that. The total length of the yarn tied together is 33 1/3. Beautiful. I know, only math people like that one, huh? Everyone should like that one. My brain likes that one. All right, a truck driver, so we're on number 5. A truck driver drove 35 2/10 miles before he stopped for breakfast. So he went 35 2/10 before he stopped for breakfast. I'm going to put a B here. I feel like I should be doing a number line, but I'm going to stick with the tape diagrams. Then he drove 5 times as far before he stopped for lunch. Oh, okay. Well, so this is actually very similar. So 5 times would be 1, 2, 3, 4, 5. So each of these is worth 35 2/10, right? So I should label these all, but I'm not going to keep going. So how many times are we multiplying 35 2/10? It's not 5. We want to know the whole total here. So it's 6. 6 times 35 2/10. Now I know I'm going to have to erase this because I have to do 6 times 35 and I don't have enough room. So let's do, what's 6 times 35? Bet you some of you can do it in your head. But I am going to draw it out. 6 times 5, 30. Regroup the 3. I don't care if you put it up there. It doesn't bother me. Oh, sorry, this is slanted. 6 times 3 is 18, 19, 20, 21. So we have, remember that gets distributed here, and Penny says hello. So we have 210 plus 6 times 2 is 12/10. Oh, you know what? I can pull out, nope, not 0, 1. I can pull out 10/10 very easily here. Instead of actually dividing it, I'm left with 2/10. 10/10 is worth 1, so I add, excuse me, I have to go over here because I don't have a lot of room. 210 plus 1 is 211 2/10. So that was actually a little bit easier one. Again, drawing it was definitely the way to go. How far did he drive that day before lunch? So before lunch, he drove 211 2/10 miles before his lunch break. Because you can't forget to add in that breakfast time too, before breakfast. Excellent. And our last one for the day, Mr. Washington's motorcycle needs 5 and 5/10 gallons of gas to fill the tank. Tank. 5 and 5/10. His van needs 5 times as much gas to fill it. 1, 2, oh, so this is supposed to be motorcycle. 3, 4, 5. If Mr. Washington pays $3 per gallon for gas, how much will it cost him to fill both the motorcycle and the van? So this is a two-step problem, because we know that this is about gallons. This all should be labeled in gallons, and then they're asking about how much money. So clearly we have to do two separate things. So the first thing we're going to do is obviously figure out how many gallons he needs to buy total. And then the next part will actually be pretty easy, because we just have to multiply by 3 to get, every 1 gallon would be $3. So if I label that correctly, that'd be great. I add them all. How many are we multiplying by? 1, 2, 3, 4, 5, 6. So we are multiplying by 6. 5 and 5/10. Why 6? Because he needs 5 and 5/10, and he needs 1 5 and 5/10. And if you add them together, you get 6. Okay, so 6 times 5 is 30, plus 6 times 5 is, oh, look at that, 30/10. 30/10 is the same as what, boys and girls? 30 divided by 10 is 3. So we need 33 gallons. So how do we figure out how much money that is? If we need 33 gallons, and each gallon is $3, is that right? Yeah, it is. Let's multiply. He needs, well, not he, Mr. Washington needs $99 to fill both the motorcycle and the van. If you had a $100 bill, he'd get $1 back. Maybe he'd buy a little snack. Gas stations have great snacks. All right, so look at that. We did it. It would have been fun in class, but we can do it from home too, can't we? All right, boys and girls, no math tomorrow. Well, no math lesson. You can go on Zern. That would be great, because no one's really going on Zern, and you really need to go on Zern. All right, I'll see you soon.